Resume. Okay. I'm funny. All right. We could try to do this like the wind itch. Um, problem one, section one. Everyone should have attempted problem one. That was the most straightforward one to me. You need three things. You need to say that it's a two-sample z-test for a difference in proportions. By the way, that is called the inference method or inference procedure. Some people were asking me what that meant on a different question. That just means what type of test or interval. Um, correct null hypothesis of equal proportions and correct alternative hypothesis of unequal proportion. Um, I put P1 minus P2 equals 0. P1 minus P2 does not equal 0. The suggestions in this were P1, P2, P young, P old. Um, and then there was like P18 or P55. Do you guys understand what I mean? Okay. And then referencing the two groups, 18 to 55 years of age, 56 years and older, and all exercise center members. Somewhere, something. If you only have two of the three of those, that's a P. Otherwise, that's an I. Any questions about that? You guys, for section one. There's four sections, I believe. Three sections. There's three sections. Okay, section two. You have to say that there's two random samples. You have to say that what on earth? Oh, it's the 10% condition. We don't do it like this. It doesn't matter. You just have to meet the 10% condition. Your large counts condition numbers are 55.25, 114.75, 74.75, and 155.25 are all greater than or equal to 10. Correctly reports the Z statistic, which is, okay, it's negative 0.918. However, I saw all the way to like 0.86 or 0.85, depending on rounding, and it was totally correct. It was just rounding. These guys went all the way to 3.435. I went to 3.43, and some people did 3.4. It's okay. You're not necessarily wrong. It's just, it probably is rounding. Just make sure that you have P hat C in those two spots. And then the corresponding p-value, which was 0.359 after you multiplied by 2. Okay, so those four pieces. Random, 10% was part 1. Large counts was part 2. Z statistic and p-value. Those are the four pieces. Yes. Separate's fine. It should say separate. What's wrong? Oh, there's three. There's three. The last one's the conclusion. Okay. Okay, provides correct comparison of the p-value to alpha. The p-value is greater than alpha and provides a correct decision. That means that you failed to reject the null hypothesis. States a conclusion in context in terms of the alternative hypothesis. Mine was, we do not have convincing evidence of a difference in proportion of all exercise center members age 18 to 55 who would be interested in taking fitness classes and the proportion age 56 or older who would be interested in taking fitness classes. If you have both of those, that is an E. One of those is a P. None of those is an I. And remember what I said, if you forget how to do the math, just come up with a reasonable p-value. Anything between 0 and 1 is a reasonable p-value. Just don't put like 1.6 or something like that. That doesn't make any sense. But anything, just say, I forgot how to calculate the p-value, so I'm going to pretend that it's 0.02. since our p-value of 0.02 is less than alpha, we reject the hoe. Again, they cannot mark you wrong twice. So if they mark you wrong for the math, you go with your wrong answer for your conclusion, even if your conclusion is different from theirs. Everybody got it? Okay. All right, number 2. Oh, not number 2. It's got the same kind of scoring. All 3 have to be E's for a 4, 2 E's and an I for a 3. All the middle stuff is a 2. 1 E and 2 I's is a 1, and everything less than that is a 1. Okay, number 2. Number 2 had some weird wording that I found confusing, but I was hoping that maybe you would pick up on. Okay, the first section is the segmented bar graphs. The top one should look like this. The bottom one should look like this. So the elementary school bar graph is one component. The middle school bar graph is the other component. If you have both of those correct, it's an E. One of those correct is a P. Neither of those correct is an I. Any questions about that? That was one of my favorite parts. The only part that I didn't like was that the wording of this made it seem like the middle school had an equal proportion to the elementary school, not equal proportion to themselves, which I didn't like that bit. But other than that, okay. B, you need 3 components. You need to say no somehow, or incorrect, or some kind of decision about no. Then you need to say the middle school sold more bottles, small bottles, than the elementary school, and include something about bottles. So you just have to say something about context. I said, no, even though the proportion of small bottles is larger for elementary school students, the actual number of bottles sold was 3 times the number of bottles sold by elementary school students. Do you have any questions about that? You needed all 3 of those for an E, 2 of the 3 of those for a P. Everything else is not. Okay, C. There's 4 components to C. You have to say high school A sold a greater proportion. And you have to reference the height of the rectangles or the decimals on the y-axis, or something about relative frequencies being 0.7 versus 0.6, something like that. And then you have to say high school B sold a greater number because the area of the rectangle is larger. Yes.
For instead of things like 0.7, could you put a difference of 0.1?
Yes. You actually only had to say, if you wanted to, that the height of high school A was higher, or the height of the bar of high school A was higher than the high school B bar. You didn't even have to say numbers. But I always say numbers if I can say numbers, because sometimes they care a lot and sometimes they don't. I don't know which is going to happen. So I always reference numbers if I can. If you have 2 or 3 of those components, you get a P. Otherwise, you get 9. This is the same type of scoring. Okay, number 3. Part A, there's 3 components. You have to say it's an observational study. You have to say something about no treatments being imposed, or they were not forced to do anything, or they were not told to do something, or they did not have have to follow something specific. And then you need to say something about cars and mileage, something like that. It says no random assignment of treatments works. Um, does anyone want to ask if theirs was okay? The second provides a justification based on no treatment being imposed. So something like, I just said there were no treatments imposed. So you could say they were not, no, it's not enough. Yes. I think so. I think, hold on. Is there anything else? No, I think something, you could say something about where they simply observed the mileage off of each speedometer would be okay also, but they are pretty specific here about no treatments being imposed. And one of the things I wanted to say is if you get asked this question, clearly that's what they want. So let's do that from now on. Say there was no treatments being imposed, or there were treatments being imposed if they ask you the opposite. One of the reasons we go over this. Okay. The next bit is probably the hat method for you. Depending on what you did, it says three things. You have to create appropriate labels for the treatments. I did mine, number of the days 1 through 70, or number of slips of paper 1 through 70. Describes how to correctly implement the random process so every possible random assignment is equally likely. There's so many different ways to do this. I said number identical slips of paper 1 through 70, put them in a hat, choose 35 slips without replacement mixing between, assign those 35 to the autopilot feature and the remaining 35 to not have autopilot. Some people did like flip a coin. Some people did like 2 slips of paper and you have autopilot on one and not autopilot on the next. And then the first 35 that you pull out. I thought that was cool too. Some people did rand int no repeat, 35 unique numbers. The first 35 are autopilot, the last 35 are not. And then you need to say, some 35 of them get assigned to autopilot and 35 of them get assigned to not autopilot somehow. Yes.
Like 1 to 35 or something not
Perfect. Perfect. It's perfect. It's wonderful. Oh, hey, look what they said. Man, you got on the model solution page, James. It is. Okay. Last part of this. It says, I actually don't know if I did this correctly. I just put random sampling is required from all cars from the club. I didn't know. Oh, no, no, no. Ha, 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 ha. I did get it because I said add random sampling. Ha, ha, look at me. I just slipped through. Almost had a P there. Whew. Okay, anyway, you have to say that cars must be randomly sampled or included or something, including random sampling. You have to random sample or you have to do it over, including random sampling or something like that. And then the population has to be Model D cars from the club. So, okay. They didn't really say here what they said that you had to say over here. I think what you can say is that you can do it over. Like you have to do it, he has to do it over, I think is what they're trying to say. I don't know why they said more. Anyway, whatever. Okay. Sometimes College Board is awesome. Sometimes not. Okay, number 4, which I think is the hardest one of the whole packet, the geode problem. I remember in 2024, the kids, you know how like, there's memes and stuff about certain FRQs. This was the one, the geode problem. And it was because the students forgot that the expected value, mean and standard deviations formulas were on the yellow sheet for geometric. So I'm making sure to point that out now. They just completely forgot the formulas were on the yellow sheet. Anyway, number 4A, part 1, correctly calculate the mean, which is 12.5 geodes. Show your work for the mean, which is 1 over 0.08. Correctly calculate the standard deviation, which is 11.99 geodes. Provides supporting work for calculating 11.99 geodes. It does not say anywhere that you have to say the word geodes. I highly suggest that you put units on everything, though. Any questions about that part? Okay, just so you know, binomial and geometric, expected value is the same thing as the mean, and the mean and standard deviation formulas are on the yellow sheet. The yellow sheet will be in the packet. That it won't be yellow, it'll be white, but it's going to be in the packet that they give you. Okay. All right, part B calculates the probability of opening 3 geodes, that is 0.0678, and provides supporting work. Let me show you my supporting work. I did Geomet PDF 0.083, being sure to label your P and X. So it should look like this. Don't forget to put those labels, all your normal CDFs, TCDF, Geomet, binomial, anything out of the calculator, just label it. Okay, then this is the bit that I thought was hard. The 4 is not really just 4. It's 4 and everything else, 4 and up. So you do the complement of everything else in the table. You don't just do Geomet 4. You do 1 minus all of the other things that you had. So 1 minus 1, 2, and 3 together, which is 0.7787. So you need the Geomet answer, which is 0.067, correct work. You need the 1 minus for the rest of the table, and then the correct work. Okay, remember, all probability tables have to add to 1, right? So you should have just found that third one and then added them all to 1 immediately without even flipping that page over. Okay, part C, you have to have the correct mean, which is 3.545 geodes. You have to show appropriate work, which kind of is annoying because there's only 4 of them. You only need to show the first 2 and the last one, but there's only 4, so you might as well show them all. Okay, and then you have to say something about many trials. You have to say something about on average. And then you have to say something about either a red geode is found or the 4th is opened, whatever comes first. Okay, it looks like you need at least, okay, wait. You have to have 1 and 2, and then you have to have 2 of these to get an E, not all 5. So if you missed one of these 3, that's okay, you still get an E. Okay, number 5. I liked number 5 much better than I liked number 4. Oh, hold on. It has the same sort of, number 4 has the same sort of scoring. Okay, number 5. Part A shows the correct probability of 0.518 with work. 0.518 with work. You need to have this bit here showing the numbers being added together. Just pretend that they're in kindergarten and they have no idea what they're doing. And okay. B provides the correct probability with work. The correct probability is 80 over 91, which is 0.879. For me, I'm not going to show this piece because I don't use the formula when there's a table given. I just look at the part of the table, and this is what I wanted to say. A lot of people were trying to do fancy stuff with the formula here. Don't do that. Just go like this. Oh, given fewer than 6 months, that means the whole rest of the table doesn't get used. What's the probability you have a majority of regular baseball cards? 80 over 91. Don't make it complicated. If you have a table, use the table. Don't try to go all into the probability formulas. I mean, it works clearly. Look, the 500s cancel, but why? Okay. Part C. You need to say it's a chi-square test for independence or association. For the hoe, you need to say there's not an association or relationship. You can copy the word relationship from them. And then you need to say there is an association for the ha and then context. So that baseball cards business. How many of you guys recognize the chi-square? These are easy ones to get correct, so keep your eyes peeled for chi-square. I hope to have a chi-square on the test. It's always good because you just type it in the calculator. It's wonderful. Okay, anyway, if you have 2 of those, that's a P. You can also get a P if you state chi-square test for homogeneity and then do your ho and ha based on homogeneity, which is kind of nice. Sometimes they're nice. I don't know what to expect. It's like your moody relative where you're like, how are they going to be today? I don't know. That's College Board. Okay, last bit for that. I guess there's 4 bits for this one. P-value is less than alpha, so you reject the ho. And then conclusion in context, I said we have convincing evidence of an association between the number of months collecting baseball cards and which type of card is the majority in the collection. 1 or 2 of those is a P. None of those is an I. Almost done. Okay, and I want to impress upon you a couple of things here. Question 6 is intimidating every single time, but it's easy. It's just a lot of reading. Hunt for the little formula they're going to give you and plug numbers in. Really. It's consistently the same dealio. Okay. Oh, hey. Number 5 is scored differently. Each E is 1 point. Each P is a half point. And if you're somewhere in between, you have to go on vibes. No, I'm serious. It's vibes. Holistic approach. What am I supposed to do with that? It's like could make or break somebody on just someone's thoughts and feelings. Well, this person has nice handwriting. Someone around it. Like, I don't know. What do they do? Draw them a little smiley face and say, you look nice today. Like, I don't know. right? I showed this to Mr. Knight the other day and his head just about exploded. 'Cause we're math teachers. We don't grade on like subjective stuff. Anyway, okay. Last one. Part A has 3 components. You need to say it's a one sample t interval for means. Why is it an interval and not a test? Very important. Wanted to just pause on that. Because it wants to provide an estimate. You won't get any numbers from a test. You'll just get a yes or no answer, but an interval will give you a plausible range of values, which is an estimate. Okay. Part 2 identifies the correct parameter by including reference to the mean. I mean, mu equals the true mean price in dollars of this whistle at all stores that sell the whistle. And part 3, reference to all stores that sell the whistle, price of the whistle. Whistle. I'm gonna say whistle more times than I've ever said whistle in my entire life. 1 or 2 of those is a P, otherwise that's an I. Flip the page. By the way, that is the least amount of writing on one page of an AP test, like of all time. I don't, anyway. Okay. Part 2, 4 components. Say that it's right skewed. You need to say that it's right skewed for a reason. And in this one, they said it's because the mean is higher than the median, or the mean gets pulled into the tail, or something like the mean is not resistant to skew and outliers, so it will be higher than the median, or something about that. What did I say? Right skew because the mean is higher than the median and the mean will be pulled into the tail. Nice. Okay. 3, no outliers by correctly calculating the lower and upper outlier criteria with work shown. So the lower boundary is, no, yeah, the lower boundary is 3.0625. The upper boundary is 6.9225. So there are no outliers because there's no numbers outside of these 2 boundaries. How many people had to go back and look this up? It's like at the end of the summer work. Okay. If you have 3 of the 4 of those, it's a P. Otherwise, it's an I. So if you just did the first part and forgot and just didn't look up the 1.5 times IQR rule, that would be an I in that situation. Do you remember it now, though? So do you know how to find the IQR? Okay, wait, hold on. Do you know how to find the IQR? Okay, this minus this minus this. Okay, then you multiply by 1.5. That's why it's called the 1.5 times IQR rule. My joke of the day. Okay, then you take that number and subtract it from Q1, and that's your lower boundary, and you add it to Q3, and that's your upper boundary. Anything outside that range is an outlier. Okay. Is this the last part? No. 2 components for part C. You need to plug the numbers in and get 0.949 with work shown. And then put an X right there on this weird graph. If you have one of the 2 of those, that's a P, otherwise it's a not.
One of them.
It's a P. Do you see where the coordinate came from? 0.949 comma 20. Just okay, last thing. Okay. Sample is strongly skewed. What did I say? Oh, yeah, it's in the strongly skewed region. That makes, I was wondering where those words came from. They came from the graph. Okay, so say that the sample is strongly skewed by saying that it's in the in the on the graph in the strongly skewed region, or says that the Pearson coefficient makes the strongly skewed or something like that. Um, then you say the normal conditions not met. Oh, so it has to be a no. And then sample size of 20 is less than 30, which explains that it's strongly skewed. Oh, I see, because there's 2 bullet points. It's been a good 365 days since I dusted this packet off, so I didn't read the problem because I'm just an excellently prepared teacher. I was too busy playing Cozy Caravan before you guys came in. Okay. All right, so this is another one of those where you add it up and then use vibes at the end. Okay, here's my next question. Gonna pause my